Question 2. A ray of light travelling through air is incident at an angle of 40 degrees on the first surface of a crown glass prism n equals 1.52 at an angle of 60 degrees. Calculate the angle of emergence of the ray at the second face. So we need to draw a diagram for this. It helps if we get approximately the right angle. So this is our equilateral triangle. We know it's got an angle of 60 degrees at each corner. This arrives and it says the angle of incidence is 40 degrees. So we're going to mark that in there. That angle is 40 degrees. And we're asked to calculate the angle of emergence. So we need to work out what happens as this light ray passes through. We might first of all just mark in its path approximately. So at the first surface it bends towards the normal. So it's going to come across something like this. We're going to call this angle theta 1. Then it arrives at the second surface. We draw a normal. Because it's a triangle, we need to work out a new value for this angle, theta 2. And then when it emerges, it bends away from the normal, so not that line I've just drawn, but further from the normal, so somewhere down here. And this angle we're going to label as theta 3. So to work out the value of theta 1, we need to use Snell's law. So we're going to say n1 sine theta 1. Let's not use 1 because we've already defined what that is. So I'm going to call this formula now NA sine theta A is equal to NB sine theta B. We want to find the value of theta B. So that is NA sine theta A over NB. Then we need to inverse sine that as well, don't we? So let's move that part across. That. So that is the refractive index of air, which is 1 times the angle of incidence sine 40 over the refractive index of the glass, that's 1.52. So that tells us the size of theta B, which in my diagram is labelled as theta 1. So let's use that from now. So that gives us 25 degrees. So let's rub out where we've labelled theta 1 and write 25 degrees. Now we need to do a bit of maths with our triangle. So if that angle there is 25 degrees, then this angle in here is 90 minus 25. So 65 degrees. If that angle is 65 and this angle is 60, then our third angle in this triangle must be 55 degrees, which means that theta 2, our second angle that we need, has a value of 90 minus 55, so 35 degrees. Then when we get to the second surface, we've again going to need to use Snell's law. Let's write in a new colour. NA sine theta A is equal to NB sine theta B. This time I want to find theta B, same as last time, so theta B, but on my diagram this is also called theta 3. So theta 3 is equal to the inverse sine of NA sine theta A over NB. This time it's starting in the glass, so the refractive index of the glass is 1.52 multiplied by the sine of the angle of incidence at the second surface, which is 35 degrees. I've forgotten the inverse sine again. Turn across. Over the refractive index of air, the medium it goes into, which is just 1.0. So this gives us our angle from the second surface, which is 61 degrees. So theta 3, the angle at the second surface, 61 degrees, and we worked out this internal angle here is 35 degrees. The last part says the angle of deviation of the ray passing through the prism. So this is how much its direction has changed. We can do this at each surface. So at the first boundary, it went from 40 degrees to 25 degrees, so that means that there was a deviation of 15 degrees. At the second boundary, it went from 35 degrees to 61 degrees in the same direction, so it bent to the right as it came in, and it bent to the right again as it crossed the second boundary, so two deviations in the same direction. So this second deviation, also with the same sign, is 26. So adding those two together, we get a total deviation equal to 41 degrees.